Technology Risk Part 11. This episode has 17 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Scenario: Failed access review. An access recertification review reveals 12 terminated employees still have active production access. How do you respond and remediate? Here's a strong way to approach it. Revoke access for all 12 accounts immediately. This is the urgent action regardless of root cause investigation timing. Then check whether any of the accounts were used after the termination date to determine if this is a stale access finding or an active incident requiring deeper investigation and possibly breach notification. Root cause: the process gap, usually a broken offboarding trigger between HR systems and IAM, and fix the integration or add a compensating automated control. A scheduled job that cross-references Active Directory or IAM accounts against HR termination records daily, so this doesn't rely on a periodic manual review to catch it months later. Nice. Let's continue. Question 2. Scenario: Conflicting risk appetite. Business wants to launch a feature that security rates as high risk. How do you drive the decision to resolution? Here's a strong way to approach it. Get both sides reasoning into a shared, concrete format rather than a values debate. Quantify the specific risk. What could go wrong? Likelihood. Business impact if it materializes, and the specific cost of delay. Revenue. Competitive timing. So the decision makers are comparing real numbers, not vague positions. Look for a middle path first. A scoped launch, compensating control, or phased rollout that reduces the risk enough to proceed. And if no compromise closes the gap, escalate to whoever owns risk acceptance authority, typically a risk committee or an accountable executive with both positions documented, since resolving genuine risk appetite conflicts is a governance decision, not something to settle by whoever argues harder. Great. Moving on. Question 3. Give examples of each in cloud infrastructure. Here's a strong way to approach it. Preventive. Org policies blocking public IPs or public buckets. Detective. Alerts for IAM changes, disabled logging, or public exposure. Corrective. Automated removal of risky firewall rules. Secret rotation. Restoring from backup, or rolling back a failed deployment. Together these controls create defense in depth. Alright, next question. Question 4. Difference between ISO 27001 and NIST. Here's a strong way to approach it. ISO 27001 is certifiable and focuses on building an information security management system. NIST CSF is a flexible framework for improving cybersecurity risk management. ISO is often used for formal certification and governance, while NIST is often used for practical cybersecurity maturity and control mapping. Let's keep going. Question 5. Shared responsibility model. Here's a strong way to approach it. The shared responsibility model defines what the cloud provider secures and what the customer must secure. The provider secures underlying infrastructure, while the customer manages configuration, identity, data, network exposure, application security, logging, and compliance. In managed services, responsibilities vary by service type. On to the next one. Question 6. Risks of public cloud. Here's a strong way to approach it. Public cloud risks include rapid misconfiguration at scale, internet exposure, complex IAM, data residency issues, vendor dependency, shared responsibility confusion, cost surprises, and inconsistent governance across projects. These can be managed with landing zones, org policies, IAM standards, monitoring, and automated guardrails. Good. Here's another one. Question 7. IAM best practices. Here's a strong way to approach it. Use least privilege. Avoid basic roles. Use groups. Prefer service account impersonation over keys. Use workload identity for GKE. Apply IAM conditions where useful. Separate duties. Review access regularly. Monitor policy changes. And remove unused permissions. Privileged roles should be time-bound and approved. Nice. Let's continue. Question 8. Risks in Kubernetes clusters. Here's a strong way to approach it. Kubernetes risks include overprivileged RBAC, privileged containers, exposed API server, insecure images, missing network policies, secret leakage, weak admission controls, noisy multi-tenancy, vulnerable nodes, and insufficient logging. In GKE, I would use workload identity, RBAC, private clusters, binary authorization, and policy controls. Great. Moving on. Question 9. Risks of Terraform automation. Here's a strong way to approach it. Terraform risks include accidental destructive changes, state file exposure, privilege misuse, drift, poor module design, unreviewed plans, provider bugs, and secrets in variables or state. Controls include remote state encryption, locking, approvals, plan review, policy as code, version pinning, and least privilege CI or CD identities. Alright, next question. Question 10. State file security in Terraform. Here's a strong way to approach it. Terraform state can contain sensitive resource data and sometimes secrets. It should be stored in a secure remote backend with encryption, access control, locking, versioning, audit logs, and limited access. Secrets should be kept in secret managers, not hard-coded into Terraform variables or outputs. Let's keep going. Question 11. Secrets management. Here's a strong way to approach it. Secrets should be stored in managed tools like Secret Manager or Vault, encrypted, access controlled, rotated, and never printed in logs or committed to code. Workloads should retrieve secrets through secure identity, not static files. CI or CD systems should mask secrets and restrict who can read or update them. On to the next one. Question 12. Cloud misconfiguration risks. Here's a strong way to approach it. Common misconfigurations include public buckets, open firewall rules, broad IAM roles, disabled logging, unencrypted data, public databases, unrestricted service accounts, and missing backup policies. I manage them using org policies, posture scanning, IAC checks, alerts, and ownership-based remediation. Good. Here's another one. Question 13. Risks of CI or CD pipelines. Here's a strong way to approach it. CI or CD risks include secret leakage, weak branch protection, untrusted dependencies, compromised runners, excessive deployment permissions, missing approvals, lack of artifact integrity, and poor rollback. Strong controls include least privilege, signed artifacts, approvals, scanning, protected branches, and audit logs. Nice. Let's continue. Question 14. Risks of GitHub actions. Here's a strong way to approach it. Risks include exposed secrets, unsafe pull request workflows, third-party action compromise, broad tokens, self-hosted runner abuse, and unpinned action versions. Controls include least privilege tokens, environment approvals, pinned SHAs, secret restrictions, branch protection, OIDC federation, and runner isolation. Great. Moving on. Question 15. Risks of Helm charts. Here's a strong way to approach it. Helm chart risks include insecure defaults, excessive privileges, hard-coded secrets, mutable image tags, unsafe templates, and unreviewed third-party charts. I mitigate these with chart review, values validation, policy checks, pinned versions, signed charts where possible, and environment-specific approvals. Alright, next question. Question 16. Kubernetes RBAC risks. Here's a strong way to approach it. RBAC risks include broad cluster role bindings, default service account misuse, wildcard permissions, privilege escalation through pods or secrets, and unclear ownership. I reduce this with namespace scope roles, least privilege, access reviews, audit logs, and separating human, workload, and CI or CD permissions. Let's keep going. Question 17. Risks of privileged containers. Here's a strong way to approach it. Privileged containers can access host resources and bypass container isolation, increasing the risk of node compromise. They should be blocked by default using pod security admission, gatekeeper, or Kyverno, with exceptions only for justified platform components and strong monitoring. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.